April Simons here with the McWhorter School of Building Science at Auburn University. Today we are talking about load tracing. We're continuing the series on load tracing here. The previous video covered some of the basics about load tracing with some of the terminology. Today we're going to work an example problem doing gravity load tracing. One of the best ways to understand any structural concept is to just dive in and work a problem. So we're going to do that today here with gravity load tracing. What we have here is a system of structural elements. So if we start at the top here, we have beams. So we have actually 10 of these structural beams. Supporting the beams, we have 2 girders. And supporting those girders, we have 4 columns. If we look at the bottom here, we have some given information about the structural system. We know that the length of the beams is 8 feet. The length of the girders is 10 feet, and the uniform loading on the beams is 48 pounds per foot. So if we think of a real-world scenario here where we might have a system like this, it could represent a lot of different things. But what we actually have here is part of a bigger structure. So in reality, this structure would support a roof loading, maybe even some equipment loading. And we've taken this part of the structure out so that we can see it better and perform this load tracing on this portion of the structure. And what we have here with this uniform loading is basically we have the beams that you see here, all 10 of them, have a uniform load, which we denote with a little W. And that uniform load for each of these beams is going to be this 48 pounds per foot. Okay, so in other words, for every foot of length of beam, we're going to have a loading of 48 pounds. So what we'll do is we'll trace this load of 48 pounds per foot through the beams. We'll go to the next structural element, which is the girders. And finally, we'll find the loadings on the columns. So as a reminder, there are 10 beams in total here. Okay, so all of the gray elements here that you see represents the beams. So we have 10 of these beams. Each beam looks the same and carries the same load. So again, each of the beams has a loading of 48 pounds per foot. So if this is our beam, and we look at each of these beams individually, we have a loading of 48 pounds per foot on each of those beams. And the beams are supported by girders on either end, right? So we can see that the left end of this beam is resting on a girder. The end of this beam, okay, is resting here on a girder as well. So if we look at that, each of the beams will have a reaction with the girders. So between the beam and the girders, we have this reaction. So we'll call this R girder and R girder here. Right, so as a reminder, the beams are each 8 foot long. So if we look here at the length of the beams, we have 8 feet. Okay, and again, we have 10 of these beams, but since they all look the same and have the same loading, the same length, and they're all supported by girders, we can do the calculations for the beam and girder reactions just one time for all. When we have a situation like this where we have a beam or a girder, any horizontal element like this that has a uniform load across the entire object. Okay, so here we've got 48 pounds per foot over the entire beam. We don't have any point loads on the beam or any other unique loads to deal with. We can simplify the equation to R equals WL over 2. Okay, that's only in the case here where we have a single uniform load, no point loads, no triangular or other unique loads. So our equation to find the reaction at the girders here, on each end, R girder left and R girder right, is WL over 2. So again, W is that uniform load. So that load is 48 pounds per foot. We multiply that by the length of the beam. Okay, again, each of these beams are 8 foot long, and we divide by 2. We divide by 2 because we have a reaction on the left side and the right side. So if we do this, we get R is equal to 192 pounds. So this is our reaction force. So the reaction between the beam and girder on the left side equals 192 pounds. And the reaction between the beam and girder on the right side equals 192 pounds. So again, we have 10 of these beams that are resting on the girders on either end. We just calculated that the reaction between the beam and girders are 192 pounds, so on each end. So here we have 192 pounds between girder and beam. For the next beam, we have 192 pounds, and so forth. So again, we have 10 of these beams. So if we take the girder itself and sketch it here, okay, again, noticing that the girder itself is resting on columns. Okay, so we have a reaction, okay, a girder reaction with the columns on the left, a girder reaction with the column on the right. Okay, as a reminder, these girders are 10 foot long, okay? So we have a 10 foot long girder that has 192 pounds every foot over 10 feet of length. So we can simplify that with a uniformly distributed load of 192 pounds per foot. Okay, so now we have a uniform load on the girder just like we did on the beam. So now we have two of these girders, and again, both of them look the same. They're both 10 foot long. They both have this uniform load of 192 pounds per foot that comes from the beams, and they're both resting on columns. So we can again use our simplified formula where the reaction is equal to WL over 2. So now our reaction, again, is going to represent those column reactions. Since there's two column reactions, we divide by 2 here. That's where we get the 2 in our formula. So we have our girder uniform load, 192 pounds per foot, times the length of the beams, or girders here, 10 feet, divided by 2. Feet cancels here. So we end up with 960 pounds for the reaction. So we've got a column reaction here on the left, 960 pounds, and a column reaction here on the right of 960 pounds. So now we've completed this example problem for vertical load tracing. Again, we've got a simplified problem here where we have a system of beams, girders, and columns. Any structural system we look at when we're doing vertical load tracing, we just want to start at the uppermost element and work our way down through the structure, which is what we did today. So we had a uniform loading on the beams. We took that uniform loading, found out the reactions between the beams and the girders. We took that and traced that load through the girders and found the reaction between the girders and the columns. So this is how we would complete any load tracing problem when we're looking at vertical loads or gravity loads. And we just want to start at the top of our structure, whatever that structure may be, and follow those loads through all the structural members until we get to the foundations.